So once you have selected a template, you can now click the alignment. You have multiple methods you can choose, and for what they do, you can refer to the correlation document um, in image processor. So before you do the alignment, you might want to check the options first. Go to particle analyzer. You have multiple options to choose the how do you want your particles to appear in the alignment. You can choose only using the masked particle area in the alignment. You can choose to crop a box extending beyond the particle mask area so that I can see its surroundings better. Or you can choose only to show the mask particles without its surroundings, but you can also choose to show particle area with its surroundings. So yeah, we have three options. So for this protein, and we don't want to crop area, we only need to see the particle well. So you can just pick up these only visualize mass particle array. So we don't want to see the surroundings because sometimes the two clones may come close together. So you don't want to see other proteins in its surroundings at all. Um, so that's what we need, and now you need to just click alignment. So now we have the template that's highlighted, and there's other matches they would align with the template. Um, so as you see, it's aligned pretty well, and bear in mind that the correlation analysis that we use in the image processor, I only use a 10-degree interval, so it's already did a decent job. If you want to have like perfect angle match, you might want to reduce that rotation interval parameter to like 2 degree. So I also use some other tricks like symmetric. I check all the symmetric boxes. So just bear in mind, this is a very rough correlation analysis. Apparently, the program have done a very decent job in alignment already. Um, so now you can refine this process. I mean, just to manually take off the particles that's not well aligned. So one thing you can do, there are multiple options in this context menu. I'm not going to explain them all, but many of the like selection just give you options to, many of these are just for convenient in your picking those particles. Category assignment, I'll talk about that in category particle categorization tutorial. And the other thing you can do is you can select another particle as template, so which means the program will redo this alignment process by using this particle, for example, as a template. And there's a last item which labeled in red in the manual. So this tells you where the particle is, like from which image it comes from, like what the particle number is, and its correlation coefficient. So the correlation coefficient is labeled as the title of each particle. That's the correlation coefficient of this particle that's correlated to the template. The other thing you can do is, right now I don't see any outliers that, maybe this one. So for just use this example. So if you don't want to remove this one, you can actually remove multiple ones. So the selected ones, they are labeled with a green circle, and the deselected one, they are labeled with empty circle. So for example, if I want to exclude this particle, you can just deselect it and right click and say remove particle of the deselected particle from the list. Once you click that, and that particle is gone. Yeah, the system is a little slow in the processing because that I use the screen recorder, but yeah, it's usually pretty fast. Not like that. Just bear in mind. So right now, I think they are good. I mean, you can also use some other computerized automated measures to exclude particles. For example, you can use the correlation coefficient as criteria to exclude some particles. Let's see. You can um, do these, like select particle based on quality number. For example, if I only want a higher quality match, I can say like 0.9. Apparently, there's only 1.9 there. It could be that this is not very good template. You might want to pick up better template. That's what I usually do. So to do that, we pick up, like for example, this as a template and say select this particle as template. So the program will realign these particles using the new particle as a template. So right now, apparently, we have that one. Now in this case, you can do not just multiple 0.9 there. So apparently, the particles match up better with the new template, and that's um, important because some template are better than other template, right? And now you can do is select particle based on coordinate number 9. Now you can say that the lower bound is 0.9. Then what it does is all the particle that's below 0.9 they are excluded. And you can also do this like color label selected particles. Let's say label it by a red color. So all the particles that are about 0.9 they are now labeled. Now this is just like a visual aid, especially helpful if you have, right now I have 17 particles, right? But you have like near 100 particles, so this will be pretty useful to aid your manual review process. And apparently, I think some of these they're kind of curvy, so that's why they're not quite aligned with these dumbbells, which is pretty straight. Um, so I would so you can also use the correlation coefficient, the lower one like 0.85. It will be a bad match versus a template. So I actually think so. This is like computer calculated results. Apparently, some of them I would like to think they are a good match. So including this one. Maybe this curvy one I wouldn't use them, but I think these one are a good match. Right, so basically we go back and forth of these. On the one hand, we use the computer to help us, like doing it quickly. On the other hand, we manually review the ones that's selected by the computer and the one that's deselected by the computer. We add ones that we think are true from the discarded ones by the computer. We we throw away ones that's false positive, even though they are selected by the computer. So we go back and forth these procedures, and finally we get a selection of particles that we have final, some kind of a mixture of our own judgment and the judgment from the computer. So finally, I can do the correlation averaging of the selected particles. Click that. So what this gives you is it gives you the template and the correlation average results. As you see, the average result is pretty, is much better than the template image in terms of resolution and just overall quality. So right, you can also do an overview which of the particle that's selected, but this does not give you the alignment. But from the overview, it gives you an idea of the randomness. Just give you an idea. Let's see. So for example, if you give an overview, they are not aligned. As you can see, the R really have various orientations. That's great about this program because it calculates their rotation factor and realign them, and then in the end, so this is the aligned results, comparing this with the aligned results, so you get an idea of how great the program is. So finally, you can also fine-tune your match finding. For example, I already match up with 17, but I already exclude one. But if you want to refine this process, you can adjust the slider bar. This is especially useful, and it's only used once you click the find button. So this will, it's like an undo process. You can, so if you click find using 85 as a criteria, if you want to fine tune that parameter 85, you want to use like a slightly larger and small number of that quality, but use the same particle as a template, then you can use the slider bar. So all this does is if you adjust slider bar, it uses the template of the last time of your choice, and then it chooses a different quality. Then it reduces particle finding. So for example, if I go higher, then apparently there's only this one particle, which is a template. If I go lower, so gradually you will find more particles. If it finds, now it finds another one, so we know 18A we have like 5 particles. If you want to find more, let's say like 76, now it finds how many particles you find. Now I find 74 particles. So and that's, you know, close to the limit, because 74 is a lot of particles. If you do alignment, you can expand. There's like 74 particles in this one screen, and it's not very good for your manual review process. So I would usually keep the particle number smaller than 100, so not above that. So it's really good to start from small number of particles first. So the other option you can do is you can check these no categorized particles. So when you do the correlation analysis, you want to categorize them. For example, these are the particles that have dumbbell shape. So you can assign the categories to these particles. I'll talk about that in the categorization tutorial. But so once you have set categories to your selected particles, now you can check this box and then do the match again. So in the next find process, the next time you click find, it will exclude those particles that are already categorized. So this helps you faster your process. With some particles, they might have matched with other particles. So when you click find, you don't find all the particles, right? So when you redo this, use a new template, right? Then you will find more matches, but you'll also find the original matches as well, and you don't want to do that because you already categorized them. So this will be helpful if you check this box. Then you won't have to re-encounter those particles that are already categorized. So in the end, so once I did this procedure, I would, so right now these particles, assuming they are already categorized, the next step I would do is I would click another particle. For example, this one. This is also like a dumbbell shape, but it's a little shorter. And then click find again. So this might match up with some of the dumbbells that are already categorized, but this time when I click find, because I checked this box, no categorized particles, it will not find the particles that I found the last time. So